All right, so we are adding and subtracting fractions today. And so I just want to review with you guys what you already know about this and what you should know. So if I had like 1/3 plus 5/12. Okay, you're adding, so you have to have common denominators. And if I look at this, 3 goes into 12, so my common denominator would be 12. So I would have 12 here in the denominator, and I need to turn the other equation into 12s. So what would I multiply this 3 by to get a 12? Well, I'd multiply it by 4, so if I do the bottom, I got to do it to the top. And this already is 5, so now once I get common denominators, I would have 9/12, right? Now, sometimes you can simplify that. So in this case, 9/12, 3 goes into them, so my answer is 3/4. But sometimes you can't simplify it, so you're going to have to get the adding done first before you can simplify. Okay, now I might do one like 5/7 plus 2/5. Now the common denominator is not, 5 doesn't go into 7. So then what you did when you were younger, you did 7 times 2, that's 14. 5 doesn't go into 14. 7 times 3 is 21. 7 times 4 is 28, doesn't go into it. 7 times 5 is 35. Now, if you know what the common multiple is, you can just go to it. I'm just trying to remind you because they're not all going to be this easy. We're not even going to be working with numbers. So what would I multiply 7 by to get the common denominator? I would multiply by 5. And what would I multiply 5 by to get the common denominator? I'd multiply by 7. So when I add that, I get 39/35, which is my answer. It doesn't simplify. So you can't check to see if it simplifies until you get a common denominator. All right, so if I look at my examples for today, some of your homework is just going to ask you to find the LCM, which means the least common multiple. So this question, example 1 and example 2 are different because example 1 is all multiplication. So you're just going to multiply to get like the smallest thing that goes into it. So you're going to have to make it bigger. Okay, I made 7 bigger by multiplying by 5. I made 5 bigger. So you're going to make things bigger. So I would do it a piece at a time. So if I look at the numbers, I would start with 20. They don't go into 20, so 20 times 2 is 40. They don't go into 40, then 60. Well, 15 goes into 60, but 16 doesn't. It has to be something they all go into. 80, 16 goes into, but 15 doesn't. 100 doesn't work. 120, if I divide by 15, that's 8. And if I do 120 divided by 16, it's 7.5, so that's not it. So then I'm going to do 140 divided by 15, nope. 160 divided by 15, nope. 180 divided by 15, that's 12. 180 divided by 16, that doesn't go in. So then 200, 220 doesn't work. 240 divided by 15 works. 240 divided by 16 works. So my number is 240. Okay? And now you're going to look at the A's. You don't even have an A in the second one. So you have an A squared and an A to the third. The least common multiple is A to the third because you can turn A squared into A to the third by multiplying by A. But you can't go backwards, so you're making it bigger. Okay, then you're going to look at the B's. So you have a B to the fifth, and you don't have a B there, so your multiple is B to the fifth. Because you can turn a B into B to the fifth by multiplying by B to the fourth. And then finally, you're going to look at the C's, and so it's C to the sixth. So this is my least common multiple. Okay, to do the next one, example 2, you can't do the least common multiple until you get it factored. So the first thing I'm going to do is I'm going to take an x out. So that's x squared minus x minus 2. And then I'm going to factor. Factors of 2 that subtract to 1 would be x minus 2 and x plus 1. So that is that one factored. Okay. Then I'm going to factor this. It would be x minus 2 and x minus 2. So they share. I'm going to go ahead. I'm going to write this so you can see this. Wouldn't this be x minus 2 squared? So it's kind of like when you have an a and an a squared, the least common multiple is the bigger one because they are the same. So my least common multiple is everything that isn't the same. Well, you have an x. You have an x minus 2, and the biggest one is squared, and then you have an x plus 1. So this is my least common multiple. And take a look at that. You may have to look at some examples in the book. I don't know right now what to kind of tell you, but you're looking at the biggest one. So you might want to watch that again. But it might come to you when we do some of this other stuff. Okay, so on this first one, the first thing I would do is what I did up there. I would figure out what your common multiple is. So between 6 and 14, I would do 6 doesn't go into 14. 28 is 14 times 2. 6 doesn't go into that. 14 times 3 is 42. Well, 6 goes into that. So my least common multiple is going to be 42. And then my biggest a is a squared and my biggest b is b squared. So it would be 42a squared b squared. That's what my common denominator is going to be. So now what I'm going to do is I'm going to look at each fraction. I need a 7 to make the 42. I need an a squared and I need a b. So I'm going to times by 7a squared b. So that's going to be 35a to the 4th b. And now if I look at the other, I have the a squared b squared, but I need a 14 to become a 42, so I'm going to multiply by 3. Okay, so now I add like terms like you did in junior high. So 35a to the 4th b plus 27 over 42a squared b squared. This is very important. I cannot take anything out of the top. Nothing goes into 35, that goes into 27. So the only way you can cancel 35a to the 4th b plus 27, this all goes together, is if you have exactly the same thing in the denominator. Some of you are going to try to do some form of fairy math where you sparkle some dust on it and you cancel out a's. You can't do that. That is the answer. There's nothing that you can't cancel an a squared because you don't have an a squared with the 27. So you have to have it in every term. That is your answer. That's it. There's nothing to simplify. Okay, so what I would like you to do right now, I would like you to pause and I would like you to try example 4 on your own. Okay, it's in your notes. And so you can watch me do it, but if you don't try it and see where you messed up, you're not going to understand this. So pause. Try it. All right, so you're going to get your common denominator. So between 12 and 2 is 12. And then if I look at my x's, my biggest x is an x. If I look at my y's, my biggest y is y squared. So now I'm going to look at each individual fraction and I'm going to see what's missing. I'm missing a 6 to get to 12. I have a y, so I just need a 6xy. So that is going to give me 18x to the 3rd y. And then if I look at my other one, I'm not missing anything. So I don't have to multiply by anything at all. So I end up with 18x cubed y plus 5 over 12xy squared. Can you take anything out of the top to cancel with the bottom? No, there's no common multiple. This is your final answer. If you tried to cancel x's, you have to have an x in both terms on the top to be able to cancel it. Okay? So just understand, you add order of operations. You would add the top before you do the division. Okay, so let's take a look at example 5. On example 5, I would not do anything with example 5 until you factor the bottom. So this would be a 3 and then an x minus 5. And this would be a 6 and an x minus 5. So if I look at this, right, I have the x minus 5 in both things already. So I'm going to just write that here, x minus 5. And now I'm going to look at these numbers in front. I have a 3 and I have a 6. What's the common multiple between 3 and 6 is a 6. So what is the first fraction missing? It has the 3, but I need a 6. So don't I need to multiply this first fraction by 2? So that would be 2x plus 20. Because you have to multiply the 2 into both of them. Okay, and then on the second one, I have what I need. I do not want to factor the top because the rules for adding are you leave the denominator alone. Oops. And you add the top. So that's going to be a negative 1x 20 minus plus 5. Okay, so now I want you to think about this for a second. I could take out, this might be easier for you to see if I took out a -1. Wouldn't that leave me with an x minus 5 if I took out a -1? Now look at, oh, I hate this thing so bad. Now look at these two sets of parentheses. Now that I've taken out the -1, are they exactly the same? When parentheses are exactly the same, they cancel. And so this answer is actually a -1/6. Okay. So now if you look at the next one, I would like you to pause and I would like you to try it on your own. Okay. And then I would like you to check and see how you did. Okay. So if I do the next one, I would take out a 2. That gives me an x minus 2. I would take out a 4. That gives me an x minus 2. If I look at this, my x minus 2's are the same. So my common denominator would be 4 parentheses x minus 2. Okay, so what is the first one missing? The first one is missing 2 because the 2 times 2 is 4. So that would give me 2x plus 10 minus 3x plus 8. So if I add the top, that's a -x plus 2 over 4 and then x minus 2. If I take a -1 out of the top, and some of you might see this without taking out a -1, I would make these two parentheses exactly the same. So those would cancel and my answer is a -1/4. So it's really simple, similar to the one that we did. Okay, so now on example 7, there's quite a few of these. They love these on the ACT. I would strongly suggest, I'm going to use purple and I would do this whole top, ignore the bottom and get it all by itself. So like it's just a fraction over, like a bar, just not 2 fractions added. And then I would do the whole denominator and then divide. So let's forget about the bottom. I'm going to use purple here. What would be my common denominator between A and B? Wouldn't it be AB? So I would times the first one by B, so that would be B. And I would times the second one by A, so that would be A. So wouldn't this fraction be B minus A over AB? Okay, all I did was take care of the top because I can't even copy dot flip because it's a fraction and a fraction. Okay, so now I'm going to highlight this in green. Oops, I'm not highlighting it. Okay, and I'm going to do the same thing. I'm going to ignore the top and I'm just going to do this problem on the bottom. Don't I need AB? And you could put BA, it doesn't really matter. Okay, and here I would multiply by A, so I'd get A. And here I would multiply by B, so I would get B. And so this fraction would be A plus B over AB. Now, this whole thing is being divided. So it was separated by a division sign. So now that I just have one fraction divided by one fraction, I can multiply by the reciprocal. Okay, if you look at this, these ABs are multiplication. You can cancel multiplication. Okay, those are out in front, and so you can cancel them. Is B minus A the same as A plus B? It is not. Like if I put B is 3 and A is 5, if I put 3 minus 5, that's a -2. If I do 3 plus 5, that's 8. That doesn't come out to be the same number with just a sign thing. So your answer is B minus A over A plus B. So you have to do each fraction separately. Now I want you to pause, but before you do that, I would like to put this over 1 and make it a fraction. So do the whole top, do the whole bottom, and then multiply by the reciprocal. Pause and try it. So on the top, my common denominator is going to be x, so that's going to be 2 over x minus 1 over x. Okay, and on the bottom, my common denominator, well, let's finish the top. That's going to be, oh my gosh, that's not 1 over x. I've lost my mind. It's late. So that's x over x because that's 1. So then 2 minus x over x. Okay, so now I'm going to do the denominator, and my denominator would be xy. I just like to put it in alphabetical order. If you put yx, that's totally fine. It just makes sense to me to put it alphabetically. So my first fraction is missing an x. My second fraction is missing a y. And so that's going to be x minus 3y over xy. So I'm going to multiply by the reciprocal. So now if you look at this, my x's would cancel, and I end up with y parentheses 2 minus x over x minus 3y. That is my final answer. I can't do any simplifying with that. So sometimes you're going to be, you could multiply the y in, so you'd have 2y minus xy over x minus 3y. This goes back to what I kind of talked about yesterday. It depends on what class you're in as to whether you want to leave it out or put it in. So I would take both answers right now. And so it really just depends on if you're going to be graphing it or if you're going to be solving it. And we'll get more into that. So right now I would take either answer. All right, the last question, they love these on the ACT. Find the slope of the line. So remember, slope of the line is rise over run. So my rise would be 4p minus 1/5, because those are my y's, divided by my x's, which would be 1/4 minus 5p. This looks really similar to what I just did. So if I do the top, my denominator would be 5p. So I'm going to multiply this one by 5, so that's 20. I'm going to multiply this one by p, and so that's p. So you end up with 20 minus p over 5p. And then I'm going to do the denominator. So you would have 4p and 4p. So the first one I multiply by p, and that's a p. And the second one I multiply by 4, and I get 20. So that's going to be p minus 20 over 4p. So now I'm going to copy dot flip. So I'm going to come down here. I'm going to go a little higher so my stuff doesn't get in the way. So I get 20 minus p divided by 5p. Multiply by the reciprocal, 4p over p minus 20. So if I look at this, these p's out here would cancel because they're multiplication. And if I look, 20 minus p is the same thing as p minus 20, except when I divide, it would divide to a -1. Because if I put like 12 in, 20 minus 12 is 8. 12 minus 20 is a -8. When you divide that, you get a -1. So this answer would actually be a -4/5. That is the answer to this question because my p's cancel and these would cancel to a -1. Okay, so again, I would strongly suggest working through these. Make sure you take a look at like the delta math and stuff because I am not going to spend a lot of time on reviewing this when I get back. We're just going to learn how to graph these.